In this video, we learn about evaluating triple integrals. So the same technique that we use to integrate double integrals is the same procedure that we're going to use when dealing with triple integrals. Let us look at the following problem. We want to evaluate the following triple integral. We are given the limits 0 to 2, 0 to x, 0 to x plus y. So when we analyze the problem, we have dz to be inside. So which tell us that in the inside, we have the limits of z starting from 0 to x plus y. Then in the middle, we have the limits of y because we have dy. This tells us that the limits of y start from 0 to x. Alright, and then in the outside, we have the limits of x. Then the limits of x start from 0 to 2, 0 to 2. Remember the rule, we have said that it is advisable for us to solve the problem step by step. Let us first start by integrating the inside to the outside. So we are going to focus on this problem only first. This part up to dz. So let us write it down here. And we have the following: 0 to x plus y, e to the x, y plus 2z, dz like this. So we want to integrate this part with respect to z. So this is what we will get. So when we integrate this part, we check here with e to the x. So this one will be treated as neutral with y plus 2z. So which means that we are going to integrate everything here with respect to z. When we have a term which does not contain the variable z, it means we'll multiply by the variable z. This is what we'll get. Then this will be e to the x. Then in the inside, we have y plus 2z. Because we integrate with respect to z, then we multiply y by z. So we have z, y plus. We integrate with respect to z, then we'll have 2z squared over 2 like this. The limit will run from 0 to x plus y, 0 to x plus y like this. Then let us move. We have the following. As you can see that these two will cancel the 2, and then e to the x inside will have z y plus z squared. The limits run from 0 to x plus y. This is what we have for this problem. So what we can do right now, remember, we integrated this problem with respect to z. It means now where we have the variable z, we have to substitute our limit. So let us now substitute the limit. We have e to the x, and then inside we have y, we have z, which means that where there is z, we're going to substitute the upper limits first. Then let us keep y, and then where there is z, we put in x plus y like this, plus z, we have z, then we have to substitute x plus y all squared, right? Then minus, we have e to the x, then we have z here, then z is a 0, so everything multiplied by 0 will be 0. 0 squared is a 0, then e to the x multiplied by 0, this will just give us a 0. So let us continue. It means that we'll have e to the x, then multiply y inside, then we get xy plus y squared plus. So because of the square, it means now we have to remove the square, then we'll have the following: x plus y. I'm sure you know this. X multiplied by x squared plus x multiplied by y, xy plus y multiplied by x, xy plus y squared. So which finally give us x squared plus 2xy plus y squared like this. Then let us check any possible like terms that we can have in this expression. So we have xy and 2xy, and then we also have y squared and y squared. We can add the like terms which we have. Then if we add the like terms, xy plus xy, then and then this one is a like term. Let me leave it for now. Xy plus xy plus 2xy, this will give us a 3xy. So I will write x squared plus 3xy. Y squared plus y squared, this will give me plus 2y squared, like this. So now listen, this expression which we have here will be used to represent the inside part. So which means that now this is what we have, 0 to x. Instead of this part, we write this expression. All right, so we'll have e to the x squared plus 3xy plus 2y squared. Then dy dx, then dy dx. All right, then let us move. Then now we want to take this part and integrate it with respect to y. So let us take this part only and work with it separate. Then we'll have 0 to x e to the x. All right, then we'll get x squared plus 3xy plus 2y squared dy. So we want to integrate this expression with respect to y. All right, so let us integrate. This is nothing but equal to e to the x. Then when we integrate with respect to y, it means we'll multiply x squared by y, then we'll get y x squared plus 3x. Because we integrate with respect to y, it means we'll have y squared over 2 plus 2. We integrate with respect to y, we add 1 when we have 2, we'll get 3 over 2, like this. All right, so it follows that when we check here, do we have any possible like term? We can have like term, but so it's not necessary for us to take the like term out. We can take this expression and replace what we have here. So what else do we have? All right, we have the limits. We've said that the limits will run from 0 to x. All right, let me not forget the limits. So let us now substitute the limits. Because we integrated with respect to y, it means now where we have y, we have to substitute the limits. We have e to the x. Instead of y, I will put in x, then x times x squared, I will get x cubed plus 3 over 2x. So x multiplied by where there is y, I will put in x, then x squared multiplied by x. This will give me x cubed, right? Plus, what do we have here? So this is over 3. This is 2 over 3. Instead of y, we substitute x. So we'll have x cubed. Then because we have y, and y, then when we substitute zeros, everything here will give us a 0. So there's no need for us to write that 0. All right, so now we have this expression. So let us try to check any possible what we call any possible like term and stuff, and then we add them up. So this is what we have. We have e to the x, then we have x cubed plus, when we check here, we have 2 and 3. And then since these terms are the same, let us take LCM or LCD of 2 and 3. LCD of 2 and 3 is nothing but a 6. Then 6 divided by 2 is a 3. 3 times 3 is a 9. This is what we have. Plus, because of this x cubed, we must have x cubed plus, then 6 divided by 3 is a 2. 2 times 2 is a 4. 4x cubed, like this. And then let us move. We have e to the x, and then x cubed plus 9 plus 4. 9 plus 4 is 13. So we have 13x cubed over 6. All right. So now when we check here, x cubed, then it means you are going to multiply 6 here. So we will have e to the x, then 6 multiplied by x cubed. This is 6x cubed plus 13x cubed, all this is over 6. What is 6 plus 13? 6 plus 13 is nothing but 19. So we'll have e to the x 19x cubed over 6. When we check here, 19 over 6 is just a constant number. And then since we deal with integrals, remember, constant, when we have them in terms of integration and integrals, we can simply take them out to be the coefficient of the integral. So let us take 19 over 6 out. So by taking 19 over 6, we get e to the x to the power 3. So now this term which we have here will be used to replace what? This part. Alright, so for the sake of space, let me write this information in a new page. So we have 0 to x. Yeah, 0 to x. This is what we have. No, 0 to 2. Then we'll have this part, 0 to 2. And then this one will be replaced by this part. So let me write this here. Then the integral of 0 to 2. Then in space of whatever we have here, I'm going to write 19 over 6. 19 over 6 e to the x. Then this is 19 over 6 e to the x cubed. Alright, then check. We have dy. dy is one thing with this term. Then what is left now is the x. So let me put in the x. The constant, remember, let us take it out. And then we have 19 over 6, 0 to 2. What remains is x cubed e to the x. The x, right? So this is the last part that we want to integrate. How can we integrate this? Because we have x and we also have x here. This part can be integrated using integration by parts. Alright, when we want to use integration by parts, we use the following rule. Remember, we have this rule where L, this one our logs. We have logs like ln, then I is the inverse. So we can have the inverse or the arcsine, the arccos, and many more. So A is our algebraic function like x cubed and stuff. So we'll have three ratios: sine x, cos x, what. Then exponentials, we can have 5 to the x, e to the x, and stuff. Alright, so when we want to choose our u, we're going to use this rule. So let us now look at our problem. We have the following part. When we check here, x comes first because x fall under the algebraic functions. This one, and then this one is an exponential. It will come last, which means that when we check without even using the Lie rule, then this one, when we differentiate it, it will become easy for us. Then at the end we'll get the constant. But this one, when we differentiate it, it doesn't change. It will remain e to the x, even when we integrate it. So let u to be x cubed, then differentiate u, we get 3x squared dx. Alright, then stop in there. Then this one is our dv. Our dv is given by e to the x. Alright, then what is v? v is just e to the x, like that. So remember the rules for integration by parts. And then it says that it's a u dv is given by uv minus v du, like this. All right, so we've said that this is our u, this is our dv, and then let us now substitute. Let us now substitute with 19 over 6, 0 to 2 x cube e to the x, okay, dx. uv, what is our u? Our u is x cube, this is our v. So it follows that we have x cube e to the x, right? Then minus the integral of v. What is v? v is e to the x, and then du is given by 3x squared dx. So now we'll have e to the x. Then instead of writing this 3 in front right here, let me write in front here. All right, then x squared dx. This is what we have. Then this is a constant. I will take it out. And then this 19 should be included here. 19 over 9 should be included. All right, then we have 19 over 9 x cube e to the x minus 3, and then x squared e to the x dx. When we check this part again, have to be integrated using integration by parts. So let us again choose our u this time around is x squared. So du is 2x dx, and then dv is e to the x, hence v is e to the x. All right, let us move. We have 19 over 6 x cube e to the x minus 3, open bracket, uv according to the same formula. What is your u? This is your u, and this is our v. Then let us multiply the two. We get we have x squared e to the x minus the integral of v du. What is v? v is e to the x, and du is this part. Because we have 2 here, I will take it out to be the coefficient of the integral. And then inside we will have x e to the x dx. All right, close bracket. And then when we check again, we can multiply this negative 3 inside here. Then we have 19 over 6 x cube e to the x minus 3. We'll multiply 3 inside, we'll get 3x squared e to the x plus negative 3 multiplied by negative 2. This will become positive 6. The integral of x e to the x dx. Check this part. We have to apply integration by parts again. So this time around, we let u to be equals to x, then du equals to dx. Hence, dv is e to the x, and v equals to e to the x. It doesn't change. So we have the following: 19 over 6 x cubed e to the x minus 3x squared e to the x plus 6, open bracket, u multiplied by v, remember according to the formula. So we have uv, our u is x, our v is e to the x, so we have x e to the x minus the integral of v du. What is our v? It's e to the x, and du is nothing but is equal to dx, which means that this time around we have e to the x dx, close bracket. So let us move. Now we have the following part: 19 over 6 x cubed e to the x minus 3x squared e to the x, all right, plus, then you can multiply the 6 inside here to remove the brackets so that the problem can be clear or show us direction of where we are going. Then we have 6 x e to the x, right? Then multiply 6 inside here minus 6, the integral of e to the x dx. All right, so for now, when we check this part here, close bracket, this part here can be directly integrated without using integration by parts. Let us integrate this part. Then we have the following: 19 over 6 x cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6. So the antiderivative of the natural log e to the x is just the same, doesn't change. Then multiply by 6, it becomes e to the x, like this, right? So let us now substitute the limits. Remember, with the limits running from 0 to 2, from 0 to 2 like this. All right. So do we have any possible like terms here? The answer is a no. So which means that we have 19 over 6. Because we're integrating with respect to x, where there is x, now we substitute our limits. So it means that we'll have 2 to the 3. 2 to the third is 8 e, where there is x, plug in 2, then minus 3 where there is x, plug in 2. 2 to the power 2 is a 4, then e to the power 2 plus 6 multiplied by x. This time around we've said that x is a 2, it means we'll get 12 e to the power 2 like this, right? Then minus 6 e to the power 2. So let us try to multiply whatever we can multiply. 19 over 6, we have 8e to the power 2. So we have 8e to the power 2 minus 3 multiplied by 4. This will give us 12e squared plus 12e squared minus 6e squared. All right, as you can see here, okay, substitute with what? 2 minus 0. All right, I think I left the limits of 0. I did not subtract here. You must subtract. So if you subtract 0, because we have the x here, this will be 0 multiplied by this, everything will be 0. And then here, because we have x here at the coefficient, so everything will be 0, and this part, everything here will be 0. And then let us check this part. We have minus 6, so we have e to the power 0 like this. So e to the power 0 is not a 0, this is a 1. All right, so there was a mistake here. I spotted a mistake. So e to the power 0 is a 1, then 6 multiplied by 1 is a 6. All right, so this is what we have, equal to, because of space, allow me to do this, 19 over 6, and then this is nothing but a 0, right? And then we have 8e squared minus 6e squared, and then this will give me a 2. I will have 2e squared minus 6 like this. And then this is the answer. So if you want to simplify the problem further, you can multiply the 6 inside. Then let us multiply the 6 inside. If you multiply the 6 inside, we get the following. So this will be 19. Then we'll multiply the 6 inside. So 2 over 3, 2 over 6 is 1 over 3, right? So you will get e to the third over 3 minus 1. So this is the final answer that you will get when you evaluate the following triple integral. So all you have to do here is to be extra careful when dealing with triple integrals, because as you can see that there was a mistake which I have made somewhere over there of not subtracting the lower limit. So I think if you have enjoyed the video and now you can understand, try to find more problems as you can and solve them. If you come across integration by parts along the way, don't forget, use the following rule to choose your u so that you can get correct answers. Don't forget to like this video and subscribe. Thank you.